Now, Unit 3 is on Chapter 6, 7, and 8. Okay? But I usually break it up, and this is the fastest section. In other words, this is the section that goes by the quickest. All right? Oh, we finally got it 1%. It's a miracle. We are dealing with discrete probability distributions. Now, let me go to the whiteboard right quick and show you what we've been working with and go, where'd my whiteboard go? Oh, what's that? It just disappears. In Unit 1, we studied statistics. Basically, data-driven statistics, which is your test scores, and what we call the frequency distribution. Okay? Yeah. Well, turn on. Now remember, a data-driven set is a bunch of test scores, and a frequency distribution, blonde, brunettes, and redheads are classes, and then a head count. And you were able to get the mean and standard deviation from either a data-driven or a frequency distribution. Now, that was the first unit. Unit 1. You reviewed how to find the mean, median, and mode of a data-driven set, and you were introduced to what we call a frequency distribution. Which is classes on one side and what? Head count on the other. 20 to 29. 3. 30 to 39. 7. 40 to 49. 8. Okay, that's frequency distribution. In Unit 2, you were introduced to probability. Mainly, you were introduced to basic probability, additive law, and multiplicative law. Okay? Now, in Unit 3, you're basically going to get a little bit of probability mixed in with a frequency distribution. And it's called a probability distribution, which is basically going to look like this. The event and the probability. Let's think of World Series baseball games. What is the probability that a World Series is going to go 5 games, 6 games, 7 games? Okay? And you have 0.035, 0.055, and 0.010. That is a probability distribution. Now you need to write that down because It's kind of needs to be in your brain when you get into this section. Okay? It's taken the frequency distribution, it's taken the class and the frequency out, and it's putting in the event and the probability. So it's kind of, that's why it's called a distribution, because it's kind of like the frequency distribution, only it's not a head count, it's probability. Okay? It's very important that you understand that. Now, there's 2 or 3 things. Well, I'll just go ahead and get to the PowerPoint. And the reason I'm using a PowerPoint on this one is because, one, this is the quickest section, the quickest unit, and it's also the one that has the most formulas. Okay? So, all right, so I've already talked about that. The objective, sound, whatever. That's just bureaucracy. I don't care anything about that. Discrete and continuous. Make sure you remember what a random variable is. I'm not really, I don't care about that. That's just something the book puts up there. Okay. Remember what discrete means. Does discrete means measure, or does discrete mean count? It means count, Hubert. That's right, class. All of y'all remember. I'm glad y'all remembered. Meaning that it's going to be 0 event, 1 event, 2 events, 3 events, 4 events. It's not going to be 4.321. It's not going to be anything like that. It's going to be 1 event, 2 events, 3 events, 4 events, 0 events. It's going to be a counting. It's not going to be in decimals on the left-hand side of the binomial, the probability distribution. Huh? Well, yeah, but quantitative is more of a number versus things. Quantitative is qualitative, and quantitative is you're still going to count, but you're going to count how many people have blonde, brunette, and redheads versus you're counting ages. Okay, ages is quantitative, and blonde, brunette, and redhead is qualitative. You're still counting both of them. Okay. Okay, that's not where I wanted to go. Okay, well, that's fine. That's fine. That's fine. I'm not used to working with PowerPoints. Okay, a continuous random variable means everything in the middle. Somebody give me a point between 0 and 1. Well, one of you may give me 0.35. One of you may give me 0.6. One of you may give me 0.5. One of you may give me, so there's infinite amounts that's in between 0 and 1. Remember what discrete is. Remember what continuous is. Continuous is measured, and discrete is counted. All right, this is just the drill. Determine whether the following random variables are discrete or continuous. Number of light bulbs. Discrete. Good. And these are usually test questions that people get wrong on the test. I don't know why, but they do. The number of leaves on a randomly selected oak tree. That would be discrete because you count. The length of times between calls, time is measured. Okay? That would be continuous. Okay? Because it's measured. There's 3 different values of time. There's hours, minutes, and what? Seconds. You may ask, and you could debate that the length of time, but somebody's watch could say 10 minutes, and somebody's watch could say what? 9 minutes and a half. Huh? Time is measurable. Yes.
You say number of seconds.
Number of what?
Number of seconds.
Yes.
Would it still be continuous also?
It would not be continuous, but you got to have more than one person. I mean, somebody would say, well, it started when she said hello. It started when they started the conversation. It's still measured no matter what. You can't sit there and count. It's not definitive. Somebody may say, okay, when she said goodbye, it ended. Well, the call ended before she said goodbye, really. Or it says the length of time between calls to 911. That would be continuous.
And you said A is discrete.
Yes.
The fact that they burn out is irrelevant.
That's a red herring. The number. When you see the word number, that's guaranteed continuous. I mean, discrete. Okay? Okay? I didn't know it did the answers too. Golly, that's nice. Okay, what happened there? Identify discrete probability distributions. A probability distribution, I showed you a picture of it on the board, provides possible values of random variable x and their corresponding probabilities. That's all you need to write. Okay? It can be in the form of a table. And that's usually what we're going to be dealing with, the table. Or you can just draw an example. Just draw a table, put event E, and then put 0, 1, 2, 3, and then put P of E, probability of that event happening. And then put 0.35, 0.65, and 0.000. Now there is a test. There's two tests that you make sure that it is a probability distribution before you even start the problem. One is you got to make sure every one of the values is between 0 and 1. And two is when you add them up, they equal 1. Okay? That's probably going to be the next slide. Okay, this is an example. All right, look on the left. This is the event happening. The event that 0 babies are born. The event that 1 baby is born. The event that 2 babies are born. The event that 3 babies are born. This could be the probability on a full moon. I don't know. Okay? The probability of 4 babies being born. The probability of 5 babies being born. And then on the right-hand side, you have the probabilities. Now here's the test. Each one of these has to be between 0 and 1. Can't have a negative. You can't have anything over 1. And if you add them all up, what should they equal? 1. Now some books say exactly 1. I think your book says 0.9999 to 1.0001. Okay? But you got to do those two tests, because if you don't do those two tests and you go ahead and do all the calculations, you're doing it for what? No reason if it's not a binomial, not a probability distribution. There's the two tests. Write them down. You add up all the probabilities, they should equal 1. And each of the probabilities should be between 0 and 1. All the probabilities should add up to be 1, and every one of the probabilities should be between 0 and 1. So let's go back to the previous slide. 6 cents, I think of it as money, okay? Between 0 and $1. 6 cents, good. 58 cents, good. 22 cents, good. 10 cents, good. 3 cents, good. 1 cent, good. They're between 0 and $1. Okay, so they're all good. Let's add them up. All right, it's 58, and that 22, that's equal to 80 cents, is it not? That's 80 cents. Then that 10 cents, that's 90 cents. Then 96 cents. Then 4 cents. So yes, it's equal to 1. So this is a probability distribution. Each one of the probabilities right here are between 0 and $1. And if you add them all up, they equal $1 or 1. And that's those two rules right here. Now, what if it does not happen? Let's say you're doing a test or a homework problem and they equal 1.65. You mark through it and you go to the next problem. Or you say does not exist or cannot be done. Whatever the homework is asking for as far as the answer, you put it and go to the next problem. Don't sit there and do all the calculations on a probability distribution that's not solvable. Is this a probability distribution? Well, the first one, are they all positive and are they all under 1? Yes. Between 0 and 1? Yes. Now let's add them up. Well, let's see. There's 10 and 30. That's easy to add up. That's 40 cents. Then 20 cents. That's 62 cents. Then 18 cents is 80 cents. Then 96 cents. I don't think so. Looks like 97 cents. Somebody add them up. See what y'all get.
Yeah, you're right.
Okay. So this one is not a a probability distribution. Okay. So you would say does not exist, no, or you would just go on to the next problem. I keep forgetting these ladies have the answer to it. So next one. You automatically know this one is not a binomial distribution. Why? I'm sorry. Probability distribution, because the negative down at the bottom. I don't care if all of them add up to be 1. You cannot have a probability that's less than 0. You can't do it. Just like you can't have a probability that's more than 1. Let's check this one. Well, 30, 40. Yep, it is because of that 0.01, that 1 cent changed to 4 cents, so that made it $1. And there's some test questions on the test that are just asking, is this a binomial, is this a probability distribution? And we know what a histogram looks like. A probability histogram is going to look like, well, I'm going to go to the next one. Let's see, there. That's what it looks like. I'm not going to insult your intelligence by staying on this very long, but that's what it looks like. I don't even think I asked the question on the test about the probability histogram, but that's what it looks like. You just put the 0, 1, 2, 3 along the x-axis, and you put the percentage or the probability on the y-axis. Pretty simple. Here is the majority of your test right here on chapter 6. There's one of them. Write it down. Is it important? Yes. You'll fail the test if you don't know it. That is the mean of a discrete random variable. In other words, if you give me all the probabilities of a group, then what is the mean? Well, there ain't no way you can do that unless you know this formula. And it does look intimidating, but it's not, because you've already done this. You've done it in what? Finding the mean of a what? Frequency distribution. Remember all those x's and all those summations? You've done it before.
Is X in? Is X is always one in this? The number of
X is the event. P of X is the probability of the event. It'll make more sense once we do one. What is that Greek letter out in front of the formula? Mu. What a sophisticated cow says. Mu.
that you thing is
Yep. It's a M. Mu. or a sick cat says. Mew. Can't say Gary don't go mew. He goes meow, meow. So we'll go with a cow. A sophisticated cow. Mew. Mu of x, meaning the mean, is the summation of the event times the what? Probability of the event. So hopefully it'll give us an example. There we go. First thing you do, what do? Check. Check to see if it is feasible. Is it? Yes. They're all positive. They're all between 0 and 1. Add them up. We said that was 80, 90, 6, and 4. Yes. So now you're going to multiply each one of those. And then you're going to add them all up. Remember, when in doubt, look at the formula. The event is x. That's the event. That's the event. And P of x is the probability of the event. Multiply each one of them together. And then what does that funky E look like? Sigma. What does that mean? Add them up. Sum them up. Read the formula. So I'm going to take my Excel spreadsheet, and the reason I'm going to do it is just to keep it neat. And pull up the Excel spreadsheet. And X, what does it go up to? 0, 1, 2, 3, 4, 5. And P of X is, what are they? 0.06, 0.58, 0.10, 0.03, 0.01. And of course you can check on the Excel spreadsheet, just check them and see if they equal to 1, and then visually look at them and make sure they're between 0 and $1. And over here I'm going to do X times P of X. Okay, now it's kind of hard to mess this up, but some of y'all are fully capable, right? Anvil with a banana, break an anvil with a banana, some of y'all can do that. And then add those up. And once you add them up, you have the mean of your probability distribution. So mu of x is equal to 0.49. So what does that mean? Well, if this was events, then it would go to 2. That would be pretty much the average, because you can't have 1.5 events. So the average would be 2 events, or whatever the case may be, 2 babies, 2 events, whatever the case may be, based on the probabilities. Now you got to think outside the box there, okay? You can't be bucktooth, and I don't know what that means. You got to think out of the box. You're not given a head count. You're given probabilities. So the strongest probabilities is going to weigh the mean. Okay? Look at your probabilities. Which ones are stronger? The 0.58 and 0.22, Hubert. That's right, class. So you know that most of your data is right in here. So that's why your average is around 2. What do you mean?
So 1.49 is the total of that column that we would divide by.
No, you don't have to. Where's my formula? There's the formula. Now, if you look the way they do it, that confuses a lot of people. So I don't show it that.
I was just thinking average. What is the average?
That's what we just found. We found the average. So based on this probability distribution, you would say if let's say this is on it's the ward where babies are born. I always call it the wrong word, but anyway, it's where all babies are born. Okay? And you are head nurse there, and you're given the probabilities, and you say, based on this probability distribution, the average number of babies born on this floor is 2. How did you do that? I did it based on the probabilities. You've got to remember what you're doing here. You're not using head counts. You're using probabilities to establish the mean. So you got to think about that a minute. You're used to dealing with, okay, I got 5 babies here, got 2 babies here, got 3 babies here, got 4 babies here. I need to add these up, and you're not doing that now. You're finding the mean based on what? The probability. Okay? And there it is. Now, what are the 2 most important numbers in statistics? The mean and the what?
Mode.
Mean and standard deviation, Hubert. That's right, class. Glad y'all remembered. Y'all pretty much suck. Okay? The mean and standard deviation. So once you find the mean, guess what they're going to ask for next? They should ask for the standard deviation, unless they're going to put a bunch of bureaucratic slides in there. Yep, they're going to. Blah, 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 blah. Following data represents the number of, compute the mean. All right? If you wanted to do this, knock yourself out, but go ahead. We'll do it. Go ahead and write those down. It's a pain, but it's not really a pain. You only got how many going down? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 100. Oh, I didn't see that. I wasn't reading. I'm sorry. So it would be better just to do it just do it at home. Okay. But how many different numbers are there? Well, 0. There's 0. 1, 2, 3. What else? Is there a 4? There's
Yeah,
4,
it goes up
5.
to 5.
So on the left-hand side of your chart, 0, 1, 2, 3, 4, 5. Now, how do we get probability? Well, you've got to take the number that you've got and divide it by what? 100.
You can make the frequency distribution with the chart first.
Relative, and then make it relative, yes. Mm-hmm. And that's what they're probably going to do. Or you could, instead of doing all that, you could do this, which is adding up all those, and it's a pain. Okay, so what they're leading up to is the standard deviation is what they're leading up to. Okay, now this is important because we've talked about this. As the number of trials of the experiment increases, the mean number of rentals approaches the mean of the what? Probability distribution. Do you remember when I told you a long time ago that the more you do something, the more reliable it is? You remember me telling you all that? Well, it still applies. The more experiments, the more number of trials, in this case, now what is the mean number of rentals? That's your test scores. Your test scores average is going to be close to the probability distribution average the more number of trials you run it. That's what it's saying. As the number of trials, and this is important because they're going to ask you this in your homework and test questions. This is one of those fart C's that you have no idea when you read the question. Well, here it is. And the answer is the mean number of blah, blah, blah approaches the probability mean. The actual mean approaches the probability mean. Oh God, no, I'm not doing that one. Well, write this one down because there is a homework problem and it is a pain. Okay, so write this down. Write this problem down. You don't have to write it word for word, but just write it down as far as the gist of the question. Talking about the life insurance policy. And you got to think of it like this. You buy a life insurance policy. How much do you have if you stay alive for 100 years? The payment. What if you die? Somebody needs some money. You get it? You understand? And that's what you have to think about when you're talking about the life insurance. This is called expected value. No. Now, if you survive, which you've got a 99% of surviving, okay, during the time, or sometimes they use drunk drivers, sometimes they use, all kinds of different things. Sometimes they use an 18-year-old male. Why do they use 18-year-old male? No. Life insurance. 18-year-old male is going to be lower than a 18-year-old female. Why?
Those guys are stupid.
Well, if I can find it. Yeah, I'm trying to find a bale of hay because, that's where I'm leading, but I can't find it. There's my bale of hay right there. See how big they are? They're pretty big. And the tractor right there, so they're pretty big. There it is. Now, why would the life expectancy of 18-year-old be less or higher than the life expectancy of a female 18 years of age? Anybody have an idea? Could it be that males are stupid? Could it be that? Anybody?
It's not possible.
Okay, it's not a possibility. Okay. I thought that might have something to do with it.
It's because of the so
Oh, is that it? Oh, okay. Doesn't have anything to do with men are stupid. Okay. Well, I think it does. You give an 18-year-old boy a Mustang, he's going to be dead within 24 hours. Why? Because he's stupid. The 18-year-old boy is stupid. I'd say anywhere from 16 to 40. And you still have 35. You still have most of you guys grow out of stupidity at 35, but you still have 40-year-olds cruise them all. But girls, their stupidity is 15 to 18. And they grow out of theirs at 18, and they start to figure out that men are stupid. They start to. But you still got ones that, marry and stay with the ones that beat them upside the head. I still ain't figured that out. So anyway, now that we know why there's a difference, well, now I can't find it. Where was I at? Oh, the PowerPoint. That's why the life expectancy is going to change depending on the question. So if you've got a 99% survival rate What is your death rate? Starts with a C. The complement. Mr. Goolsby, were you listening that day? Wow. So what is $1 minus 99.99791? It's going to be there. So that's your probability. Now you have to understand in this problem, there's only 2 probabilities. Just like when you are born, there's only 2 freaking probabilities. What are they? Male or female. When you die, you're dead. When you're alive, you're not dead. So there's a 50-50 chance, But there is no other alternative to being alive or dead. So therefore, that's it. That's your probability. So P of X is 0.99791, and the other one is 0.002009. Now, how you got to set up the other side. What is the event? Well, one event is you stay alive. And if that's the event, you make a payment of $530 or whatever. I don't know what the question's asking. But that's going to be the lesser amount if you stay alive. Because what are we dealing with? Life insurance. Okay? What happens to the insurance company, okay, when you die? Well, you just made a $530 payment, but you died, so that means the insurance company's got to pay out what? $249,000. You see where that's coming from? And now you just set it up as multiply. What do? You take you add them up. That's what you're doing. Okay. And it says compute the expected value of this policy to the insurance company. $7.50. So you're worth less than $10 to the insurance company. What is the secrets to being a rich insurance agent? Having 1 or 2 people, or having 5,000 or 6,000 people under you? 5,000 or 6,000 insurance policies. Okay? Because the more they get, the more comes in. Now, do they want to insure somebody that smokes 3 packs a day? No. How about 18-year-old males? No. So there are some people that they stay away from. That's why you ever see these commercials? If you're 50 or 60 years old, you can still buy life insurance. Why do they have them on TV? But also the insurance companies, let's say Billy Bob Insurance down here at the corner, does he want to go after 50 or 60-year-old people? No, because they about dead in his eyes. Why? Because he's an insurance agent. He's looking for 20, 25-year-old females, 20 to 30-year-old females or something like that. He's staying away from the 18-year-olds. He's staying away from the 56-year-olds. You see what I'm saying? Because the expected value is about $10, less than $10, $7.50. Okay? The insurance company, the whole thing behind the insurance company is they don't want people to die. Okay? Because they got to pay. How many of you have heard your parents talk about insurance companies? As soon as they have a wreck, what do they do to you? As soon as you have a wreck, what do they do to you? They cancel your insurance, or what does the insurance do? It goes up. That's one of the scams of the insurance. Okay? The insurance is supposed to be you pay. They invest the money. They should know how to invest the money. They invest it. Then they got a big nest egg that they pull from. But sometimes the nest egg isn't as big as they want to be. So they're not going to pull that out of their pocket. They're just going to charge you what? More. See how things work? It all goes back to nothing is what? Nothing is free. It all goes back to that. Okay? So, that's it. That's how you find the expected value. Is that a test question? Out of 20 test questions, it might be 1. But it's not going to be the mean and standard deviation. It's not going to be that, because that's going to be 80% mean and standard deviation. Did we ever get to the standard deviation? Thought they'd have it in here by now. Okay, why can't I? Oh, I'm not on slideshow, sorry. Compute the standard deviation. Okay, y'all ready for the formula? Brrr, it's even more intimidating. Y'all should run around in circles for about 10 seconds and then run out the door when y'all see it. Y'all ready? Now, hopefully, you will look at it and say, okay, I can handle that. X squared, that means we square it. P of X is the probability, and then we subtract the mean squared. That's what you should be saying in your head. And hopefully, I use the second one, okay? There's two different formulas. I use the second one, the one on the bottom. Let's see what my phone's up to now. Oh, we're at 12%, people. It's only taking an hour to get 12%. Now I can find out who's wanting to Skype in, and I've ignored for the last 20, 30 minutes. Now, one of the reasons I show y'all to do the calculations in columns is so when you get to this section, it'll be like second nature to you. Okay? So now, I want you, on the next problem, they're probably going to give us a example. I want you to find the mean and the standard deviation whenever we get to that example. But they don't give you the variance because they don't care about the variance. Most of the time, nobody cares about the variance. All right? The only reason we need the variance is so we can find the what? The standard deviation, Hubert. That's right. So what is the variance? Take away the radical, and that's the variance. Variance is the summation of x squared times p of x minus the mean squared. And then you take the square root of that, that's your standard deviation. All right, so next, there we go. Now, I assume 58, yeah, this is the same as we did before. Now I want you to, you found the mean, you don't have to find the mean again, this is the same problem. Find the standard deviation based on that formula. They're going to put the formula on here.
You have a priority 1 message coming in on secured channel.
That's all the people wanting to Skype. Let me put this, good gracious alive. Ding, ding, ding. Some Russians. Okay. Who's this? Okay, that's Miss Moore. And who is this? Okay, that's Miss Already. Miss Already, both of ours died. She's not listening. She's gone back. She's drinking heavily and probably passed out. See, she didn't even answer. Passed out on the couch. Right, Miss Already? See? The whole Skype thing's a scam. I know what y'all do. Y'all turn it on and say, hey! And then you'll run off and do stuff in the house, clean the house, chase the dog, whatever the case may be. Well, I didn't miss anybody. All right, so here we go. Take our handy dandy Excel spreadsheet and pull it back up. Now we got mu. What do we need? Don't we need x squared? So that means equal to this. I'll do the first one for you. 0 squared is 0. Copy it down. Let's go back to the formula. What else do we need? There's x squared. What else do we need? P of x, which we already got. We don't even have to calculate that. We just copy it over. I'm on P of x. I'm just going to copy this one right here over. Now let's go back to the formula. X squared times P of x. X squared times P of x. So we make a column. I'm not trying to be a smart aleck. X times P of x. I'm just trying to show you, if you read the formula, it will tell you what to do. I'll do the first one for you. 0. Aren't y'all amazed at my calculation power? I will even do the second one for you. 0.58. Now what? Well, you look at the formula. Go back to the formula. Okay, the summation of x squared times P of x. So that means I'm going to do what? Add them all up. And then I'm going to what? Standard deviation is equal to, well, let's go with variance. Variance is equal to this guy minus, parentheses, this guy what? Squared, Hubert. That's right, class. Thank you for the interaction. It's always nice to have a class that talks back. Y'all suck. Standard deviation is equal to this raised to the what? 0.5 power, Hubert. That's right, class. And there is your standard deviation. So again, two most important things are the mean and the what? Standard deviation. So make sure you know how to find those, because that's what's going to make up 90% of anything I give you out of Chapter 6. Yeah, it's pretty easy.
I did the minus u squared to all of the.
Yeah, you were doing the old way of doing standard deviation. So let's look and see if I have any clue what's going on. Let's see. Where's that? There we go. Dang old enter, enter, and then take the square root of that. It's a miracle. Y'all check me. Is that what I had? No, because I'd use a different formula. Remember, I'd use the second formula. They use the first formula. All right, where's my there's my variance. Okay, so you get the same answer. I got 0.8699 and 0.932684. Yep. Question. I'm just covering this stuff so well that y'all don't have any questions. The binomial probability distribution. just look over this. The experiment is performed a fixed number of trials. Each repetition of the experiment is called a trial. Flipping a coin 50 times. Write that down. Flipping a coin 50 times for number 1. The trials are independent. This means the outcome of one trial will not affect the outcome of another trial. If I flip a quarter, is it going to flatten one side of the rounded edge and make it different the next time? No, it's not. Unless you're, oh, okay, throw it down on concrete and run over it with a train, yeah, it might. So the trials are independent. For each trial, there is 2 mutually exclusive outcomes, heads or tails. You're not going to flip a coin and it's going to land on the edge. Unless it's the equinox, where you can stand the egg up. You ever done that before? Or a broom? Okay, forgive it. It's your parents' fault. The probability, you ain't never heard of that? Look up equinox. You need to Google it. The probability of success is fixed for each trial of the experiment. It is. There's no way you're going to get anything but a probability of a success or a failure. There's nothing to fix that. You can't, it's fixed. You're either going to get failure or success. Now, what do you do with all this? Well, they're going to ask you, what if? N is the number of trials. NPX, write down NPX.
Can you go back just for a second, please?
Yes. Yeah. I'm looking to see if I dropped any more power on my. No, it just gained another 1%. Good God. These monitors must not put out a lot of electricity. I'm sorry, what? What was what? N is the number of times. The 50 times, I told you 50 times I flipped the coin, N would be 50. Remember, N is always what? The largest number, Hubert. That's right, class. I'm going to fire this class if y'all don't start talking.
This not fast enough.
Q is the complement of P. I'm sorry, yeah, it is. Q is the complement of P. Now, you will hear me call it Q. This book is different from the last book we used, the Triola book. They call it 1 minus P. Okay? Q equals 1 minus P. So you can say 1 minus P, or you can say Q. I will say Q. In P and X, let X be random blah, 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 blah in the experiment. Okay. And Z and X has to be between 0 and 50 in this case. Has to be between 0 and N. Now, I'm going to give you an example of what we're asking. I flip a coin 50 times. And I have a 0.4% or a probability of it being tails. If I flip it another 20 times, what is the probability going to be of tails? Write that down. Let me just type it. I knew somebody was going to say that. As soon as I say again. I said, here's an example. Oh, I got to tell y'all to write it down. I forgot. Yeah. You flip, just hold on, a coin 50 times and have a probability of tails equaling, we'll say 0.4. What is the probability of tails, P of T, if you flip that same coin another 20 times. All right, so there is your No, we're using the actual that's observed. So you're thinking of the theoretical. Okay, this is the observed. So N, and that's the difference between the first probability we were doing and now. We're doing actual observing. That's the difference. Okay, so N is equal to 50 times, and probability of tails is equal to 0.4, and X is equal to 20. N, P, X. Write that down, because that is what we're doing. And there is a function on your calculator. And while y'all are writing that down, I'm going to freeze so I can go find it, because I always get confused. There's two of them side by side. And it's under second bars. Hold on. Let me get out of this. Pull up the calculator. I think it's under second bars. Hold on a second. I'm getting there. Second, I got to do all this stuff for y'all. Second bars. I think it's binomial CDF. So write that down. Let me check it right quick, because it won't do it if I, let's see. N is 50, comma, 0.4, comma, and 20, parentheses. I have to use the keyboard here. There we go. So if you flip it another 50 times, or another 20 times, there's a 0.56 probability that they're going to be tails. CDF. I'm pretty sure. We're going to do an example here. If it comes up wrong, then it's the other one. Because I can't remember, and I'm not going to go look it up in the book.
Mine's got like navigation.
I don't know. Where did you get yours? Amy, where did you get yours? Oh, that's one of the problems, freaking Apple. I'm sorry. iPhones make everything complicated. I'm sorry. What? Trials. Well, think about it. What's trials? Trials is 50. P is always going to be a percentage. And X is the only thing left, be 20. All right, so let's go back to the PowerPoint. And here's the example they're giving you. A player rolls a pair of fair die 10 times. The number of sevens rolled is recorded. Well, where's the rest of the question? Are they going to give it to us or what? Okay, I totally did something wrong. Hold on. Oh, they're asking if it's a binomial experiment. They're not telling us if it's okay. This is a binomial experiment. This is not a binomial experiment. Why? The 11 largest airlines has an online percentage of 84.7%. Blah blah blah. In order to assess reasons for delays, an official with FFA randomly selects flights until she finds 10 that were not on time. Not a fixed number of trials. Did they pick the first 25 flights? No. She's picking 10 until she finds what? Or she's picking flights until she finds what? 10 that were not on time. So she's not picking a fixed amount. She's just trying to find some that weren't on time. Can't do that. All right? That's not a binomial experience. Either it's fixed or it's not fixed. Which of the following binomial experience? Which of the following are binomials? This is not a binomial. In the class of 30 students, 55% are female. The instructor randomly selects 4 students. The number of X's of females selected is recorded. The trials are not independent. Why are they not independent? Because if you pick one body, remember what I told you about bodies? All right? Bodies cannot be replaced, can they not? Okay, so it's anytime you're dealing with bodies or votes, it can't be independent. And these are bodies. You can't be in 2 places at what? One time. Can you die twice? No. Can you vote twice? No. Well, yeah, but the odds are against you, okay? I'm trying to find the example. Okay, here we go. Compute. Okay, here we go. Why did we do this one first? This is the worst one they could give. According to the Air Travel Consumer Report, the 11 largest, 11 is not anything to do with the problem, had an online percentage of 79%. So what do you think that percentage is? P? Okay, N is 11, I'm sorry. 79% is P, and what is 4? X. So we're going to use NPX. Now, if you don't have a calculator, you have to do that right here. N combination X times P raised to the X power times Q raised to the N minus X. Don't even write it down because it's a pain. All right? Or you can, okay, are they going to give us the answer? Is this the answer down here? No, they didn't give us the answer. Well, why didn't they give us the answer? Wait a minute. Construct a probability distribution. God, are we ever going to get to a problem? Okay, I'm sorry. Construct a probability distribution. Using this formula. And it goes away. Okay, did y'all see where I'm a little bit confused? They tell you to do something and then they just leave you hanging. Okay, well, I'm going to give it to you. Here we go. Take the calculator and take second bars and go down to CDF and 11. What's my P? Point what? 0.79. Thank you. 0.79. Thank you. And comma 4. So the probability is going to come out to be 0%. Okay. Huh? Okay. So it says, suppose that 4 flights are randomly selected from construct a probability distribution from the random using a diagram tree. And then they don't even give you anything after that. They go to another problem. Write these down. Very important. Write them down. because you're going to see these on a test and you're going to go, huh? I don't understand. What? I had to go through scientific notation the other day for the 103 students. Well, they forget. And the reason you need to do these is because when you're doing these problems, they're going to ask you, there's one question about people watching a certain TV show in one house. What is the probability of at least one house? What is the probability of 0 houses? That type of thing.
Is it greater than or equal to one?
At least means that's the lowest number. So at least 1 means x is greater than or equal to 1. That's at least, because 1 is the lowest number. Oh, hallelujah, they're finally going to give us a problem. Skype people, y'all still there?
Yeah, I'm here.
Oh, we're missing somebody. What happened to Miss Already? Oh, bless her heart. She gave up on me. No wonder she didn't say anything. She usually talks back. Where is she? Miss Already? She done gave up on me. There she
Hello.
is. Miss Already, guess what? We've had
Chicken
bad
butt.
days. My phone was dead at the beginning of the class, so I didn't get y'all's text until after I charged it up a little bit.
Yeah.
And then yours died, and I looked down and I said, uh-oh, somebody's gone. So I'm sorry.
No, thank you.
Okay, I'm gonna get back to what we were doing. All right.
Right.
Now here is an example of a problem that, and I'm gonna try to leave that on the board long enough for Miss Already to get it. But the problem is gonna be the next slide. And you don't have to write everything. You can say at least, greater than, more than, fewer than, this way, no more than, this way, and exactly equals. So you don't have to write all the words, just write the first 2 mainly. Okay, let me go on and so y'all can write this next one down. Okay, look at this one. According to the Experian Automotive, 35%, what is 35%? P, good job, Mr. Gouldsby. You are on the ball today. 35% of all car-owning households have 3 or more cars. Okay? Now that 3 or more cars, I don't think that has anything to do with it because they give you some more numbers here. In a random sample of 20 car-owning households, what is the probability that 5 have blah, blah, blah? Okay? So you might want to write it and just mark out 3 or more cars, put blah, 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 and then 3 or more cars in the A, put blah, 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 because you need to train your mind to see what's important. Okay, so I'm going to go to my handy dandy calculator. What is n? Now that will show you a trick learned in the war. Second function, entry. Look at there. So I'm going to type, I'm going to type 20. And then what is my 0.35? And then 5. Enter. 0.2. Okay, I'm using the wrong one. Second function, it's the other one. Second function bars. I always forget it. It should be PDF. My bad. I suck. 20, comma, 0.35, and 5. Now see it comes out to be 0.12. There we go. If I made a mistake, it's PDF. Okay? PDF means probability. CDF means chance, I guess. PDF is probability. Been using the wrong one. Sorry. My mistake. I suck. I told you a while ago, you didn't hear my note? I said we'll get to the first problem, and I'll tell you that's why I was looking for the problem. I suck. You type it in the same way. It's typed in the same way. One is a probability problem, the other one is not. So I messed up. Huh? Well, if you don't know what you're doing, I'm sorry. All you do is type in the same thing. And now it's going to probably ask us for at least or more than. So here we go. Next slide. Blah, 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 blah. What is the probability that less than 4, blah, blah, blah? Okay, forget this. Mark that out. Just don't even look at that. Okay? Less than 4. So that means 3, 2, 1, and what? 0. So that means you're going to have to do this. N is what? 20, comma, 0.35, comma, less than 4 be 3. Plus 20, 0.35, 2. Plus 20, 0.35, and what? 1 plus 20.35. And what do you think the last one is? This is the probability of no houses, the probability of 1 house, the probability of 2 houses, and the probability of 3 houses. Now you're going to learn how to use that second entry and stow button, where you buy the bread. All right, here we go. So I'm going to take my handy dandy second entry, and I'm going to put 20.35 and 3. Enter. And I'm going to stow alpha A. Second entry, second entry, 2, enter, stow, alpha B, second entry, 1, enter, stow, alpha C, second entry, and 0. Stow, alpha D. And now clear alpha A plus alpha B plus alpha C plus alpha D. Enter. 0.0444. Look there, we got it right. Now you want to confuse somebody, tell them to use NPX and tell them how to type it in their calculator, and then show them how to do a problem like this without using the NPX. Now see, that's where students get confused. They see this explanation, and the first thing they go is, where'd that come from? Do it like this: 3, 2, 1, 0. You got to show it like this, so students will relate, taking the one we just did, and instead of just doing it, you got to do it 4 times. That's what this sentence right here says. That's what that says, but they don't show it. That's this right here. They're probably going to ask another one about greater than, or at least. I don't know if they are or not, because I hadn't looked at these. Let's see what the next one says. According to in a random sample of 20, what is the probability that at least 4? Okay, there's a hard way to do this and an easy way to do this. The best thing for you to do is draw a picture. What the heck do you mean draw a picture? Number line. Zero, 1, 2, 3, 4, 5, 6, 7. Go up to 11 or something, or do you just say 4? Didn't it say 11 before? Okay, good. What does this mean? That means the lowest number is what? So that means 4 and a what? 4 and above. This means 4 and above. So what are you going to have to do? Take 4 and what? And go up to however many. The initial question it said, I don't know how many. Look at the initial question. What is this question? Is this the initial question? $20. That's what I thought. Okay, so do NP4, NP5, NP6, NP7, NP8, NP9, all the way up to NP20. Or take the complement of 3 or less, which you just did. Because what's the opposite of 3 or less? What's the complement of 3 or less? 4 or what? More. Here's 3 or less right here. 3 or less. What's the complement of 3 or less? 4 or what? More. So if I want to find, there's 2 ways I can find. One is I can add up N, P, 4 through 20. That's one way to do it. Or I can get the complement. I think it's spelled with an E in math. Find the complement, and that would be 1 minus the probability of 3 or less. Now you've got to be able to see this. If you don't see it, you won't understand it. Okay, but you've got to be able to see it. The complement of 4 or more is 3 or less. The complement of 3 or less is 4 or more. So which one do you want? Well, you want 4 or more, so you got to subtract the probability of 3 or less out of 1. And that's probably what they did. Let me look on the problem and see. Where's the problem? Is that, let's say 3. Is that 3 or less? That's 3 or less. And here, there it is. Okay, this is the way they say it. 1, the probability of 4 or more is the complement of 1 minus 3 or what? Less. So that's where that comes from. I'm not going to do it because y'all should see it. Question, great. Complaint. Now this, I don't know if y'all going to be able to handle. Okay, this is some real high mathematics here. There's your 2 formulas for this section. The mean and the standard deviation. The mean is n times p. The standard deviation is the square root of mp cubed. I don't know if y'all going to be able to handle this high level math. Binomial, this is, well, right here. Compute the mean and standard deviation of a binomial random variable. You'll see in just a second when we do an example. The mean is equal to NP, and the standard deviation is equal to the square root of NP cubed. Now, how do you know this from MPX? Well, they're not going to give you an X. Simple as that. Here's the example. According to the Experian Automotive, that should be according to Experian Automotive. Should it not? 35%. What is 35? T. Hubert. Of all car on blah 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 is in a simple random sample 400 car owner households. Determine the mean and standard deviation of car owner households, blah blah blah. Well, what did we find before? We didn't find the mean and standard deviation. We found the what? The probability. You see, don't get things mixed up. We found the probability. Okay, now this is real hard math. What is 10% of 400? 40. So 30% would be what? 10% of 40. 400 is 40, right? Okay, so 3 of those would be 120, right? And then what's half of 40? 20. So what's 20 plus 120? 140. Now there's somebody in here who probably has no earthly idea what I just did. It's because you're not using your brain. It's not your fault. It's the way you were taught. 10% of any number. What's the secret to multiplying and dividing by tens, hundreds? Multiply by tens, hundreds, and what? Thousands. Whatever. Y'all get the point. Count the number of zeros. And what do you do when you multiply? You move to the what? To the right, that number. Divide by tens, hundreds, thousands. What do? You count the zeros, number of zeros, and you move to the what? Move to the left. Okay, so what is 10% of 400? 40. 10% of 400 is 40. How do you know that? Because you move the decimal place one place to the left. Okay? Therefore, 30% of 400. If 10% is 40, What's 30%? If 10% is 40, what's 30%? 120. And then what is 5%? Well, if 10% of 400 is 40, what's 5%? 20. So the answer is 40. Everybody that graduates high school should be able to do that in their head. But that's asking a lot of what? It's asking for a lot of work. Every student that graduates high school should be able to do that in their head. And if you can't, you were shortchanged. And that's just the way I feel about it. Now, I'm gonna really stress something else on. I'm gonna do that next one. I'm gonna try to do that next one without using the calculator. Well, yeah, most of the time, yeah. Well, 114. 10% of 114 is 11.4. Leave. Get out. You failed. You are a failure in life. All right. So I'm just gonna figure the variance first. Here we go. NP. Wait a minute. NP is right here. We said it was what? 140. So we already done half the math right there. Times Q. Well, Q is, what is 35%? That's P. So Q is what? 65%. Okay, so here we go. You ready? Variance is equal to, what's 10% of 140? Let's try that again. 10% of 140. 14. What's 14 times 6? 64. How about 64? I thought. Isn't it? Or 84? 84. Okay? Now, if 10%, now y'all with me? If 10% is 14, then what do you think 5% is? Oh my gosh, Mr. Booth, you are so smart. So the variance is equal to 91. Okay? Oh my God, how's he going to find it? Okay, this is some real bad stuff right here. All right, so I'm going to need to take the square root of 81 and square root of 100. That's equal to 10, and that's equal to 9. I know that 91 is in here somewhere, so I know that the difference between 9 and 10 is 9.5. That's in the middle. So if I can figure over here, then I can figure it out. And you should do this in your head. You should be able to do this in your head. All right? So, what's the difference between 81 and 100? 19. Half of 19 is 8.5. We'll use 8. 8 added on to this is what? 89. Really, it's 89.5. Oh my gosh, we only need 91. So I bet it's 9.6 or 9.7. What do y'all think? The standard deviation is equal to 9.6 or 9.7. You tell me you go through 12 years of mathematics and you can't do this in your head, you've been shortchanged. Somebody tell me what they get. Okay, 9.6. Oh, it's on the screen. No, half of 19 is 9.5. That's where I went wrong. I'm sorry. I went wrong. It's not 89.5. It's 90.5 right here. I made a mistake. That's why I still said 9.6. These are real hard. I don't think you'll be able to pass the test because these are on there. Let's see what objective 4 is. So far, we've covered the most important parts. I know. Y'all gotta go to a fire or something? Oh, you gotta cut grass. Let's see what this controller. No, I'm not gonna worry too much about these. You can do these in your homework. And if you can't construct one, we'll go over it when y'all come back, okay? Main thing y'all need to work on in the homework for right now is those formulas that we covered today. Okay? Capiche? All right, y'all get out of here. Have a good day. Skype people, have a good weekend.
Good weekend.
Huh?